Hey, in this tutorial we're looking at section 14.4 on confidence intervals. So we've seen that we can estimate the population mean from the sample means. So we're doing that in the last tutorial on 14.3. We took a number of samples and found the mean of those samples to give us an estimate of our population mean. Okay, but the problem with that is we don't really know how accurate that is. Okay, or we don't know if we need to take more samples or our sample sizes need to be larger. We don't really know. Okay, what we can do though is use a confidence interval to give a range of values for which the population mean may lie. Okay, and what that means then is we can be a certain percentage sure that the mean is going to lie within these values. Okay, often, as we'll get to in a minute, we use the 95% confidence interval or the 99% confidence interval. Now, the higher the confidence interval is, okay, the broader your values are going to be. Okay, because if you want to be more confident, okay, that your value is going to lie within a range, well, that range needs to be bigger. Okay, so I mean, you can be 100% confident, okay, that a mean will be between negative infinity and positive infinity, for example. Okay, it has to be something in there. Okay, so we use confidence intervals to give us that range. Okay, our sample mean, okay, we say is our x bar, and our sample standard deviation is just s. Okay, we're just using s for that. Okay, you could probably write sigma s or something if you wanted to. Okay, our confidence interval is given by x equals our x bar plus or minus z times s on the square root of n. So that's our sample mean and our sample deviation. Okay, and this is square root of n, that's going to be our sample size, and we've got this z value. Now that z value, okay, is given by x plus or minus x bar on divided by s on the square root of n. Okay, now that z value, okay, is going to change and be dependent on our confidence interval. Okay, so for the 95% confidence interval, okay, z is just 1.96, and for 99% confidence interval, z is equal to 2.58. So most of the time we're going to be doing questions that involve those two confidence intervals. Okay, they may ask you a tricky exam question where you need to actually work out what your value would need to be. Okay. And that's fine if you need to do that as well. What we could do is our inverse normal distribution, okay, and set our range of values, okay, do the centre tail and that sort of thing with a certain percentage and work it out from there. Okay. So what we'll do is we'll jump into a couple of worked examples. Okay, so we're going to look at worked example 5 to start off with. So after surveying the 20 people in your class, you find that they plan to spend an average of $4.53 on their lunch today. The standard deviation for your sample was 0.23. So what we're saying is our x bar equals 4.53. Okay, we know our standard deviation, s, is equal to 0.23. Okay, and we know that our sample size was 20. Okay. We need to estimate the average amount that your classmates will spend on lunch today. Find a 95% confidence interval for your estimate. Our 95% confidence interval gives us our z value of 1.96. Okay, so what we're going to do then, okay, is our confidence interval, okay, is given by, we do our x bar minus our z times our s on the square root of n, and our x bar plus our z times our s on the square root of n. Okay, so what we can do is we can find out this part first. Okay, so we can say our z times s on the square root of n, okay, is going to equal our 1.96 times our 0.23 divided by the square root of 20. Okay, when we do that, we get a value of 0.1. Okay, so that means then our confidence interval is going to go from our x bar, which is our 4.53, minus 0.1 to 4.53 plus 0.1. Okay, which means we're going to get a confidence interval, okay, of between 4.43 and 4.63. Okay, so you can say that we can be 95% confident. Confident that students we'll spend between our $4.43 and $4.63, okay, on lunch. Okay, is the way that we would be talking about that. Now, we do need that statement at the end, okay, when answering these type of questions. Okay, otherwise we're not actually answering the question. We just write this, okay, well that's not really our answer because you haven't really said what this actually is. Okay, so for worked example 6, okay, Arabella samples 102 people, so that's going to be our N, 102 people, okay, and people and finds with a standard deviation of 0.8, okay, that on average they eat 5.2 cups, that'll be our X bar, 5.2 cups of vegetables per day. Estimate the average daily vegetable consumption and find the 99% confidence interval for your estimate. Okay, so again, what we need to do, okay, is find our values. Now we know already that Z is equal to our 2.58. Okay, what we can do is find our Z score for that. Okay, so what we'd be saying, okay, for 99% confidence interval, okay, that we'd have 1% within the tails, okay, or we could say that each tail is 0.5%. Okay, so we could do our inverse normal stuff to find our Z value of our 2.58. Okay, so what we're going to do is very similar to this process. We're going to find what our Z times our S on the square root of N equals. Okay, so we know our Z is our 2.58. Okay, times by our S, which is 0.8, okay, divided by our square root of our number of trials, which is 102. Okay, so you can see here, this greater Z value, okay, is going to mean we're going to have a bigger range compared to our 1.96. And also you can see that when we increase our sample size, okay, this part is going to decrease. Okay, so this is going to reduce the variation. Okay, so what we can do then is use our stuff here, because we know that this, okay, is equal to 0.2. Okay, so then we can say that we get our X, which is 5.2 minus 0.2 and 5.2 plus 0.2. Okay, which means our confidence interval is going to be between 5 and 5.4. Okay, so we can say that we are 99% confident. Okay, values will lie between 5 and 5.4 cups of vegetables. Okay, so we'll keep moving on to our next worked example 7. Okay, now we said in worked example 5 the average amount spent on lunch was between our 4.43 and 4.63. Okay, what sample size would be needed to reduce the interval to plus or minus 0.05 at the 95% confidence level? Okay, so what we're saying then is we want, okay, Z to equal S on the square root, Z times our S on the square root of N to equal 0.05. Okay, now we know that our S was equal to 0.23, okay, and our Z is fixed at our 1.96. Okay, so we can rearrange to find our number of samples we need, or our sample size. So we can sub everything in, so we've got 1.96 equals 0.23 over the square root of N, that's our times, equals our 0.05. Okay, when we start to rearrange that, then we get that the square root of N is equal to 9.016, okay, just by rearranging. Okay, and so that means that N equals 9.016 squared. So N is equal to 81. Okay, so at least 81 people would need to be surveyed, okay, for our confidence interval, okay, to only be changing by that much. Okay. So look, that's the last worked example for this section. Okay, again, I think we can get through these questions okay. I think chapter 14 is really not too bad. I think we're going pretty well so far, hopefully. Hopefully you've been watching these videos and doing the questions. You agree that we're going okay so far with chapter 14, and I really don't think you'll have too much trouble with this section.